Accuracy and precision. Two words that we use when we're describing data and measurements. But they mean very different things, even though in everyday speech we tend to use them interchangeably. So in this video, we're going to talk about the difference between accuracy and precision and how we can use them when we're making measurements. Let's use an example of a game from a carnival or a state fair. Okay? It's called Guess My Age. Here's how it works. You may have seen it done before. There's somebody standing up, and they usually pick somebody who it's not very easy to tell how old they are, okay? And then, if you want to play it, you gather around and you write down on a piece of paper how old you think the person is, okay? Now, there's a prize, or a series of prizes, and the prize goes to the person who can most closely guess the age of the person who's standing up there, okay? So, let's go ahead and look at a game right here of Guess My Age, okay? We're at a state fair, we're enjoying our fried Oreos and our funnel cake, and we go over and we look at someone who's standing in front of this pavilion or whatever, okay? And there are a bunch of people, and they write down their different guesses for this person's age, okay? One person says 20, another person says 52, another says 18, 32, 30, and 45. Okay, so these are the 6 guesses for the age of this person. Who's going to win? Well, first of all, we have to know actually the age of the person up there. And then we have to figure out who's closest, or whose answer has the greatest accuracy. So accuracy is a fancy word that means how close you are to the actual value. Okay? So let's say that the actual value is 30, that this guy's age is actually 30. Let's look at these choices in terms of accuracy, all right? Well, the person who guessed 30, they're going to win because they got it right on. But let's look at these other choices. So 30, I'm going to write here, perfect. It's incredibly accurate because 30 is as close as you can get to the actual value. 32, they were off by 2 years, so I'll say that 32 is 2 away. 20 is 10 away, and 52 here is 22 years away. 45 is 15 years away, and 18 is going to be 12 years away. So let's rank these guys in terms of accuracy. 30 is the most accurate. 32 would be the second most accurate. It's 2 away. The next is going to be 20, because that's 10 away. Then we have 18, which is 12 years off. 45, which is 15 years off. And this guy here at 52, which is 22 years off. Okay? So actual age 30, and accuracy is how close we are to the actual value. Greatest accuracy, least accuracy. Okay? Now, there's another term that's not going to win you any prizes at a state fair, and that's called precision, but it's just as important. So, precision is about how consistent a series of values are with each other. And it has nothing to do with whether those values are right, whether they're accurate, doesn't matter how close they are to the actual value. Okay? Let me show you what I mean. Let's say we get a group of 4 people playing Guess My Age, and we each have them write down the age on a piece of paper. Okay? And we get 4 guesses of the age. 29, 31, 30, and 30. These are the 4 guesses. Okay? So, to ask about precision, we want to ask the question, how consistent are these guys with each other? They're pretty close. They're pretty consistent. We've got 29, 30, 30, 31. So we'll say that these guys are definitely pretty precise. Okay? And then we can ask the question, are they accurate? Well, if they're accurate, as we said before, they're very close to the actual value. Now, this guy's age is actually 30, and 29, 30, 31 these guys are all pretty close to 30, so we'll also say that these are accurate. Let's look at some other examples here. Okay? Let's say that we get another 4 people to play this game, and they give the following answers. 55, 55, 55, and 54 are the 4 guesses for the age. All right? Now, these are way off in terms of accuracy, but the question is, are they precise? Well, they're very consistent with each other. 3 55s and 1 54. So precise, I'm definitely going to say yes. But accuracy, are they accurate? No. They're nowhere near the actual age, which is 30. So we say no. So things can be precise if they're close together and consistent, but accurate, not at all. Let's look at another example here. Another 4 people come and play Guess My Age, and here are the guesses that they make. One person says he's 25, another says he's 45, another says he's 60, and another says he's 19. Let's look at these definitions again. All right. Are these answers precise? Are they close together? Are they consistent? Not at all. Right? We have everything from 19 all the way up to 60. Scattered all over the place. So are they precise? No. Absolutely not. And additionally, let's look at accuracy. Are they accurate? Are they close to the actual value? Absolutely not. We have everything from 19 to 60. We didn't get anywhere near 30. So we'll say these are neither precise nor are they accurate. Now when it comes to accuracy and precision, teachers and textbooks often like to make an analogy where they put a bullseye and have some sort of a target analogy. So let's talk through that right now. Here I have some very, very poorly drawn bullseyes here. And let's go and look at these first examples that I had. All right? With these 4 ages. 30, 29, 30, 31. Okay? Using this target analogy, we could say that a guess that's exactly accurate would be a bullseye, right? So 30 would be a bullseye. So we've got 2 30s that are right close here, and then we've got a 29 and a 31, which are not very far away, okay? So accurate, they're really close to the bullseye, and precise, they're all consistent, so they're very close together. So this is what a bullseye target representation of accurate and precise would look like, okay? So now let's take a look at an example that is precise, but it's not accurate. This was the one where everybody guessed that this guy was in his mid-50s, okay? So if the target is the actual age, these guys are way off here, like maybe this is 55, but they're all very close together. So all of our hits are going to be far away from the target, but close together. So here we have accurate, no, nowhere near the center, but precise, yes, because they're all together. Now, finally, let's look at the example where these numbers are neither precise nor are they accurate. Again, 30 here indicates hitting it on the nose, right here in the bullseye. All right, we've got one guy at 45, another who misses the bullseye in the other direction at 19, one who says 60, one who says 25, okay? So the point is, these hits are all over the place. They're nowhere near the center, which would be the actual value, nor are they close together. So they're not accurate and they're not precise. So in the next videos, we'll go over how we could actually do measurement problems with these accuracy and precision concepts that we've learned. But for right now, this should give you a good idea of the conceptual basics of accuracy and precision.